Should I go ahead and start another one, or?
Yeah, sure.
Point out anything on it?
No, start. Okay. So this is all of your filament, right?
Yep.
And your filament goes through, let's explain how this kind of works here. So you've got filament here that you can buy online. You can buy it through Micro Center, and they come in reels, and it's just like literally this plastic stuff that that you can goes through what's called an extruder, and it gets really hot, and there's a nozzle, and I'm going to show you a video, and literally it just prints layers.
Like a hot glue gun.
Yep, and yeah, that's a good analogy. It's like a hot glue gun. So it just prints layers and layers and layers, and then builds the layers up, and as the layers get printed, they literally dry, and they become a solid and have strength. So you can imagine anything that you can probably mill with a CNC, which is subtractive, you can do with a 3D printer, which is additive. So you're adding layers. So typically you're not probably going to find something that for this advanced for your first 3D printer. I wouldn't probably buy this whole setup as a first 3D printer, because this is pretty advanced, which is great. But like my printer that I've got a Prusa, and it has one of these rolls, connectors that has a roll, and I only can print one color at a time, which is fine usually, and I'll pass around a whole bunch of things that I print. Once you get into other colors, you get more advanced, but you can see that there's 4 reels here, and then all of these get literally switched into like a butterfly matrix, and then they go down, and if you want to print different colors, what you do is, you might start something with green, it'll do a bunch of layers, and then you can switch to blue or purple, and then it has to extrude all of that old print, that filament out, and then it starts with the new color. And sometimes that wastes a lot of filament, but if you want different colors for different prints, and you have let's say you have a button, you want to print a button, and you've got the button is white, but then you've got the black lettering around it, you can do that with something like this. There's another very important part of a 3D printer. It's called the bed. And the bed is what you print on. And it has to be extremely level, extremely level. It also has to be the nicer ones, or back in the day, they weren't heated, but now they're pretty much all heated. So whenever you print that filament, that hot filament on the 3D printer, on the heat bed, it sticks to the bed. And you want it to stick because that first layer, you can imagine, is pretty important. You want that first layer to stick. In order for you to get it to stick, the bed needs to be heated. Back 5-6 years ago, people were spraying the bed with like Aquanet and putting roller paste on it to get the first layer to stick, which was crazy. But now you get heated beds, and it sticks a lot easier. There's also different filaments that you can get. They have different properties. Your first print or your first filament should probably be PLA, we'll get into it, or PETG. Those are the easiest to print to. There are other filaments that you can buy that are more advanced, and the more advanced you get, the stinkier they get. So there's a filament called ABS that stinks to high heaven whenever you print it. Having an enclosure is good. Putting it in your basement or your garage is even better, because if you put it in the bedroom, I guarantee you ain't sleeping that night. So bamboos are very, very good. The only thing that I don't like about them is, and tell me if this is true, because I haven't kept up with brand new printers, is Do you need to plug them into Ethernet to get them to work?
You can actually load files onto the card.
Okay, gotcha.
You don't have to put them on the network. But
Okay.
that is one of the killer features, is having the app that you can. My kid says, I want a dragon. Oh, there's a dragon. And then 3 hours later, it's done.
Yeah.
It's a toy manufacturer.
The other thing about bamboo printers is they're made by China. And I think that, they probably phoned home to the motherland. So keep that in mind. But my Prusa is made in Czech. Yeah, it's the Czechoslovakia is where the Prusas are made. Crealities are made, I think, here. Sure, somebody can look it up on their phone where Crealities are made. They're from China too. Everything's probably made in China these days. But yeah, for your first printer, this is what I would do. Don't go out and buy a $1,000 Prusa. You can. I would start small. Go to Micro Center and get yourself a $300 to $400 printer and start there, and then build your confidence up, and then get something bigger. So I'm going to pass around all of the things that I've printed out for ham radio, and let me kind of go through some of the prints here. These two are wire winders. Let me see if I can get these two are wire winders. They're wire coils for a vertical antenna. So you can wind your own, it's got grooves in here, and then you wind your wire up, and then you can make a vertical, clip and I've got a clips here. And just like if anybody has had like a Wolf River coil or a buddy pole, where you have to clip on where your antenna needs to be tuned to, you can do this with one of these. So that's that. Here is just a dipole center. So your toroid would go here, and then you've got your PL239. You wrap your toroid, and then throw this on a stake or something, and throw your wire in a tree. So that's something cool that you can print. This thing is a knee board. So whenever I do CW, I put this around my knee, and I put my paddle and my radio on here, and I'm able to operate. I throw a camp chair, and I use this to operate on. So it's not, awkward. Let's see, what else? This is a top to my KX3. So how, I don't know if you guys have seen a KX3. It's a little bitty radio, kind of like a portable radio. They make these things called KX sides on them, which is like a plastic cover, but the KX sides are like $150. So you can go out on the internet, you can also buy, but you can print a cover for your radio. I guarantee you, if you've got a portable radio out there and you've got a 3D printer, somebody has probably made a cover for the knobs for it, so might want to check that out. Here's a wire winder. What wire winder did you print out?
The smallest, cheapest, chintziest one.
Oh, okay, gotcha. Yep. So wire winder. And then the cool thing, well, let's talk about this. This is, those military masks that you can get from Hamfest or whatnot? I had an issue with one because whenever you put the center together, it's got the legs, right? It's got a tripod, and then you push the poles up through the center, right? Well, that's okay whenever you got a couple together and you have a guy ring up at the top to guy it. But you can't, once you get a lot of poles together, that thing becomes so heavy that there's no way that you're going to be able to take the guy rings that come with those military masks and pull the top off that's got 5 sections or 4 sections and put a guy ring and then put the pole in. So I designed this thing that snaps together. So you've got the pole, you snap it together, and then once it snaps together, make a liar out of me. Jeez. So it snaps together, and then I put my strings through there, and then I'm able to guide the military mast. So solved a problem with that. But then these are the real cool things. So CW Morse puts together these 3D printed paddles. I'm not really sure how much these are. They're $40. So you pull the cover off of this CW Morse and you can see it's all 3D printed. And there's machined parts in here. Like I think that the pivots here, I think are like little mini skateboard bearings. And then you've got the contacts that are spring-loaded. So that's a CW key. So I'll put that in here. And then my friend Adam, K6ARK, I don't know if you guys are familiar with this CW paddle called the Palm Pico paddle. It is made in France or Switzerland or Norway, somewhere over in Europe. And it's a really good CW paddle, but this thing pushes in, and that's all it is. And it has a jack on the back. So then whenever you want to run CW, you pull the paddles out. So this, I put this in my pack, and this is my emergency CW key if one doesn't, if I've lost it or my other CW key craps the bed, I already have this one as a spare. So I'm going to pass all these things around. Please don't steal my CW keys. You can steal anything that's red here, you can steal. So I'll pass that around. You guys can play around with that. All right. So, oh yeah, a couple announcements here. Missouri QSO Party is next weekend. If you're interested in Missouri QSO Party, it is a very neat contest to get started. It's very laid back and runs both days, Saturday and Sunday. The more participants we have, the better. So if you're interested in running in the CW or the QSO Party, come see me after the meeting and I'll fill you in. But it's a good time. If you like to be the DX, like if you like to do pota and like to be the DX, Missouri QSO Party is a way for you to go out and do pota, be the DX, but if you also go out and just operate like mobile or as a rover or just setting as a county, it's a good way of getting your chops up on becoming the DX. Yeah.
No, there's an article on the website with details. You got the links and everything on there.
Okay, gotcha. Thank you. All right, 3D printing. So I've kind of gone over a lot of this stuff. 3D printing is FDM, fused deposit modeling. Basically, it's an additive process, like I said. You're doing layers. And this is, you can see the print bed. I don't know if you can see it, but the print bed is here. And, yeah. So the print bed is here, and that print bed is coming down. And as that comes down, it looks like the extruder, the hot end, stays at the same level and goes back and forth and up and down, and the bed comes down, you know, millimeters, fractions of a millimeter at a time, and that's how the layers get built up. On my Prusa, the bed is stable and it goes back and forth, and the hot end goes up and down and left and right. So two different ways that you can extrude and make layers. The cool thing about 3D printing is there's so many people that are doing 3D printing now, and there's so many developers and new technologies that are being adapted that 5 years ago, 3D printing was a pain in the butt. Now it's easy. And there's so many prints out on the web that it's great. You don't have to be a designer to 3D print or to design something. Somebody has probably already designed it for you. So I talked a little bit about CNC versus 3D. So a CNC world, you got material, and then you remove that material, you get a 3D object, and then you've got a bunch of waste. In 3D printing, you have the material, which is the filament. You add the layers, you have the 3D the object, and then you have just a little bit of waste. So not a lot of waste whenever it comes to 3D printing. So if I was getting into the 3D printing, these are probably the 3D printers that I would look at. There's that Creality Ender for $200. So you can see the print bed here is stationary, and then the hot end goes up and down. You've got the Flash Forge that has a stable, again, stable print bed, and the hot end comes up and down. And then this Bamboo Lab A1, I think that's kind of like their starter bamboo. This is the Bamboo P1S. Okay. How much is this?
1,100-ish.
11.
On sale.
Okay. Filament. I talked a little bit about filament. PLA is probably the most common, but it's got low heat extrusion, so that means the hot end doesn't have to heat up as hot. Don't print anything that you're going to put outside or in your car with PLA. It will melt because it's got low heat extrusion. Okay, but it's good for, it's cheap. It's good to print, your first prints. Go out and buy PLA. PETG. So almost everything that you're seeing in that box is made with PETG. So it's strong, it's got good heat resistance, it's pretty much UV resistant. I mean, I've got a dipole center at my house that has been out in the weather for 5 years and it's still up and running. So it's decent. And then ABS, I talked about ABS for a little bit. It must be printed in a closed air, well, it has to be in a closed system, but in an open area because it stinks. But
ABS is the type of plastic that's on your car bumpers.
oh, so he said ABS is what your car bumpers are made out of. It is hot. You have to get that hot end pretty hot to extrude it, and but it's strong. It's really strong. I throw this chart in here. Probably take a screenshot or go to your phone and type in simplify3d.com. These are all of the filaments and all of the properties. So if you have a question about filaments, this is where you go to find information about filaments. It's great. Let somebody take some. All right, slicers. So this is the process of printing something with a 3D printer. So you get the 3D printer, and then you download a shape from the internet. I'm going to show you kind of the places where you can go to search on shapes and print them or search for them. You download a file called an STL file, and then what you do is you put it into a program on your computer called a slicer. That slicer is going to take a look at all of the nooks and crannies and the vertices and all of the things that your printer needs to know how to print that shape. And it's going to slice it, let's say 1,000 times. And it's going to take that information and it's going to put it into a file. Then you take that file and you load it onto your printer, and your printer decodes that file and knows how to print that object. So it's got all the X and Y and Z coordinates. It knows how big to make the layers, and you can adjust all of those parameters in a slicer, but the slicer that comes with your first 3D printer, don't change anything unless you are printing with a different type of filament. Probably the slicer that came with your 3D printer and is probably configured with your basic attributes are probably good enough. Once you get to a point where you're getting more advanced, then you can start tweaking like the layer of your the height of your layers, or the how hot your bed is for your different elements. So I wouldn't change anything, but your 3D printer is going to come with a slicer, or it's going to be recommended that you download Slicer A or Slicer B. Prusa, my Prusa has they make their own slicer. Does Bamboo make their own slicer?
They reskin Orca.
They reskin Orca. There are many different types of slicers out on the market, but what I suggest is you get the slicer that's made for your 3D printer to save you headache. And what we can do is I can download an object, and we'll go through a slicer process. Here are some 3D print search engines. These are really good. So what we'll do is once you guys get done taking a picture here, what we'll do is we will act like we're going to search for a dipole center. So I love this printables.com. It's great. The top two are probably the ones that I use the most. So let's go to printables.com. So this is the front page of Printables. So I'm going to go up here to search, and I'm going to type in dipole center. Oh, I can't even spell D-I-P-O-L-E center. Dipole center. I know that you guys probably can't see that. So we're gonna come down to dipole center insulator, and there's our dipole center that uses window line, right? And then you've got your holes here for your wire that's going to be strung out, and then your hole for hanging up the dipole center. So we're going to download this guy. Let's see. We're going to download him, and we're going to stick him in downloads. Sure. So it just downloaded, that STL file just downloaded to my computer, okay? So now what I'm going to do is I'm going to come over here to Prusa Slicer. It's going to load. Please load. Can you load? So this came with my printer. I'm not going to download the next one. Okay. So this is going to mimic my printer, and I'm going to go up here to File, and I'm going to go to Import STL. So then whenever it's going to come over here, and I'm going to select that dipole center that I just opened, and it's going to put it on my print bed. So this is what it's going to look like after you get done printing it. So now I need to slice it. So I'm going to come down here to Slice Now, and it's going to go through the slicing process. So now what I can do is, with this slider, I can see what my printer is going to print. You can see it getting smaller and smaller and smaller down to the first layer. And then I'm going to build it back up. So that's what the slicer does. Then I'm going to export this G code, which is the code that the printer needs to use to actually know what to print, and I'm going to save it on my hard drive. Then what you can do is you can take like a USB stick or an SD card, and typically, what is USB?
Just Wi-Fi.
Okay.
You can do USB.
Okay, but you can put it on a USB stick and then plug it into that guy, and then go through the menu and print it, right?
Yeah. From their slicer, it's also set up that you can literally just go, here's my drawing, I want to use my settings from last time, send it to printer.
Yep. So you would load that G code file onto your printer and hit print, and it would start printing. Let's see. Let's go to Thingiverse. Let's see. Let's allow all. Let's search for pole center again. So here's a cool, nope, that's gonna give me an ad. So again, same type of concept here. There's gonna be a download here, download all files. And it's gonna download it to my computer. I probably have to unzip this. It's probably got an STL file in it. I'm gonna load it into my slicer. I'm gonna slice it. It's going to produce a G-code file, and I'm going to load that on the printer, and it's going to print. But this Thingiverse and printables have probably the majority of the things that you want to search on. It's probably out there. All right. Prototyping, this is where it gets into design stuff. So let's say you're a little bit more advanced and now you want to design some stuff. Tinkercad is free. It's made by AutoCAD, and it literally takes rough estimates or rough shapes. You can see all the shapes over here. You know, you've got like a donut, a toroid, a polygon, a pyramid. And you basically put all those shapes together, manipulate them, and you can prototype an object. You can export it as an STL, put it in your slicer, and then print it. So this right here, I should have brought it. Darn it. I prototyped this on Tinkercad. On my CW key, I was having carpal tunnel, and it was hurting to actually key. So what I did was I made a handle and put Velcro on the bottom of my key, and now I can grab the handle with the keyer up top, and I can key like this. These fingers were getting tingly whenever I was keying. So now I hold my key with a handle whenever I key. Fusion 360 is way more advanced. If you want, that is the creme de creme of 3D printing modeling. You can get a hobby license. You have to apply for a hobby license, but you can't make any money using the hobby license. Also, it only allows you to save 10 shapes or 10 versions.
10 editable.
10 editable versions.
You can save them into your archive.
Yeah, it's a pain in the butt. So, but Fusion 360 will do everything that you want it to do, and then some. The problem with 360 is the learning curve. You know, I didn't understand what a chamfer was, or all of these architect and design terms, had no idea what they were. All I knew was I wanted something to go like this, and I had to look up what is that thing called, and hours and hours of searching on YouTube. I just want to make a half moon that, like this guy right here. You can see where it's got like a half moon here. I just want this to divot in. How do I do that? Well, I had to go on YouTube and figure out how to do that because, I took AutoCAD in college, but I didn't pay attention. So I had to relearn everything. Fusion 360 is awesome. I wish, if anybody knows of a class that I have to literally set in a class. I cannot watch YouTube videos. There's classes out there on YouTube that's, watch these 8 hours of YouTube. Within 45 minutes, I'm doom scrolling to something else. I need to set into a class and have somebody teach me Fusion 360. So if you know of a class, let me know. A couple more slides, and I think that we're done. Octoprint. Octoprint is really cool. Octoprint runs on a Raspberry Pi. You load it as an operating system, so you flash it on an SD card. You load it on a Raspberry Pi, then you connect your Raspberry Pi to your printer, and now your printer, if it was a dumb printer, like my Prusa is a dumb printer, it doesn't have Wi-Fi built in, now my printer is now on the network. I web into Octoprint. It's got a web interface. I web into it. I load my G code for the print that I want to print, and then I can print it out of Octoprint. Octoprint also has these plugins to help level your bed. It has plugins that you can connect a webcam to it, and you can film and record your print. So you've seen these videos where people have, recorded their print and put it out on the internet. That's probably Octoprint that's doing that work. So it's got a camera recorder in it. So if you're interested in doing that, yeah, that is it. But there were some other things that I was going to do that I said we're going to get into that later, and now I've forgotten all of them. So you guys are going to have to help me. Let's take a look at. Have I 3D printed any antennas?
Like the masts themselves, and then just put your elements in from there?
I mean, the only thing that I really have done is the dipole centers and the coils that you saw. I haven't printed, like full like a Wolf River coil and connected. I mean, there are prints out there that you can get like a 17-foot whip, and it will screw down into a 3D printed base, and then you can build a coil and then tap the coil. So like, for example, you wouldn't tap it, or maybe you would tap it at the top for a 17-foot coil for like 20 meters. But I have seen people that have done that, but I have not done that.
Does the heated base stay hot the whole time?
Yeah. On my Prusa, what happens is the print bed heats up. So the process would be, I want to print something, I put it in the slicer, I load it onto my printer, and then I upload it to Octoprint, and I hit the print button. Octoprint tells the printer to start, and it goes through a heating up phase. So it heats the bed, and it also heats the hot end, the extruder, that the filament gets extruded through. Once it gets all up to temp, then what it will do is it will go through on part of the hot end, the thing that extrudes the filament. It has a sensor called a pinda. And the pinda knows exactly where and how far your extruder is off of the print bed. And it will go through, and once the bed is heated up to the correct temperature based on what you're printing, it will go through and it will take measurements on the heat bed at like, in my case, it's like 12 or 15 different points, and it's getting readings from how that bed is warped, because your bed is going to warp. I print on a sheet, a flexible sheet, so whenever the print is done, you take the sheet out and you bend it, and that breaks the mold, from the base, okay? So the print is ready to go, but it takes these measurements, and then on the back end, it says, if this is the print bed, this measurement that I got is a little bit higher than this one, so whenever I start printing over here, I'm going to just raise my hot end up just, a fraction of an inch to make sure that my hot end doesn't ram into the print bed, right? But that was a long answer to get to where I'm going here. On my Prusa, the first couple of layers, that print bed will heat up to probably 5 to 7 degrees hotter than what it needs to be to make sure that that first layer sticks, and then it will cool itself down, but it will stay hot the whole entire print. Whenever you have prints that are 12, 13, 15, a whole day long, you really have to watch them because the print bed stays hot that long, and sometimes it starts to melt, especially if you're running PLA. It starts to melt that first couple of layers, and then the print sags. You can't see it, but the print starts to sag. And then, once it gets to the top, if it's not actually printing on the top and actually extruding the layers correctly, it might not jam, but it might run, like if the print bed, the extruder is not laying down that bead correctly and it's laying it up here versus down here, you'll have these beads that get suspended in air, and then your hot end, your extruder nozzle will jam into them, and then your printer will stop. And that's very frustrating after you've done 15 hours and you've got another hour to go, and now you've wrecked your print. There's also a thing called spaghettiing, and it's exactly what you think it is. It's whenever your first layer doesn't stick, and then it just keeps going, and it thinks it's printing, but it doesn't. It's not connected to anything, and then you come back downstairs or to the room, and your print looks like spaghetti. It's just a whole layer of filament that has gone haywire. So, yeah.
When the filament comes out of the extruder, it's semi-liquid. Is it hot enough to actually weld or meld with the part because it's gone around a cycle?
I have not seen.
Melt the part.
Right, I know what you're talking about. No, once it gets extruded and becomes that liquefied filament, it dries pretty quickly. So it warms up pretty quickly. Now, could you take your finger and, your fingernail and stick your fingernail in there and it make an indent? Yes.
So my question is, the bead coming out of the filament, semi-liquid, but the part has been sitting there one cycle around.
Yeah.
Cold joints. The bead melted again.
No. The filament that is being melted just lays. It's
Fused together.
Yeah, it fuses together, but it's not that hot that it's.
Hot enough to fuse the part.
Yeah, it's hot enough to fuse the part, but it's not hot enough to melt the layers that you have already put on there. Does that make sense? Did that answer your question?
Yeah. Well, I'm thinking welding.
Yeah. Yeah. If you should probably, if you want to come in and start another one, and come in and actually look in there, and you'll see what we're talking about.
I've seen, pictures of laying down a concrete wall, but
Oh,
the concrete doesn't. It's a nice bed.
yeah, right. So he just pushed it off with his fingernails, which mine doesn't do that. I have to actually,
If
but
it hits room temperature, they actually fall off.
yeah. So see how that bed is flexible? So you can, pop the print off. And they have really gotten ingenious with the print beds here on getting it to stick, but also being able for it to actually pop off whenever you want it to. It's great.
Yeah, this one's made for PLA and it sticks really well. Het G does not stick to this one. They sell another one you have to buy for a not insignificant amount of money that works well with PTG, or better.
3D printing is like ham radio. It's a hobby with a hobby within a hobby, and then there's rabbit holes. And the rabbit holes are expensive. So, did you have a question? Yeah. The hinges on the show me.
The one that you set on your knee from CW.
Oh, the paddle.
Hinges,
Yeah, there's a rod that goes through. So whenever you print those, the
Is it like this style?
yeah, go show her that. Yeah. It's just a lot of those that he's going to show you. Yep. Yeah.
Color on this one.
And in that
So the
same
rod is
topic,
pushed through. This is
you can
printed
see
as
the
1,
flat, that's a little easier to
2,
understand, but to
3,
get
4,
those,
5,
they look like
6,
half pieces.
Yeah.
Is that the $15 ones?
Yeah. That one is the hinged one is probably 6 or 7 hours, right? Also, the one thing that you have to be aware of whenever you 3D print and you do more advanced stuff is, this is flat. This is flat, and it doesn't have any overhangs, right? It's built up. So let's say this part had a part that came over, and let's say it was like a half moon, right? Well, as you're building and you're printing that part that comes over like this, well, at some point, your extruder, you're going to be printing it almost into thin air, right? So in your extruder, in your slicer, you can adjust the print for it to have these support arms that go out and actually support the things that are cascading out. There is also a thing that you can print whenever you first get your printer. It's called Bodhi. Is it called Bodhi? Yeah, it's called Bodhi. Let's bring it. I think it's called Bodhi.
Sorry. Benchy.
Benji, yeah. Benji?
Bench.
Benchy, that's right.
It's a benchmark.
I haven't, let's see. Oh, hang on. I got to go back to Benchy, B-E-N-C-H-Y. Oh, yeah, here we go. Benchy bench.
Has a million versions of it.
Yeah, there's a million versions. Okay, this guy right here. This thing will test your printer to no end because it has overhangs, it has floating areas that the printer has to basically print out into space. It's got round areas. This is the thing that you probably want to print first to make sure that your printer is up to snuff. If your printer can print this, it will print anything. I guarantee it. Don't ask me why. I don't know. Why this is the standard, I don't know.
It looks like the original Mickey Mouse cartoon book.
That's the one you still got at home, isn't it?
Yeah. Steamboat Willie, that's what it was. Yeah.
For those of you old enough to remember, right?
Steamboat Willie. Yep. The old black and white.
Yeah?
On the cheap end, are you familiar or have an opinion of the handheld 3D printers?
Handheld?
Oh, little pen?
Yeah, the handheld.
Oh, no.
It's a kid's toy. I bought my kids one.
And it works?
They can squiggle and draw on flat surfaces and flip it up and try to do.
Do they get burned?
Well, I'd like to think they're smart enough not to.
Well, at least we have.
Only once. Just like when we learned
Okay.
how to solder.
All right. I learned something new. I had no idea that there was a.
Yeah, I've seen them. You know, $50, something like that.
Wow.
$30.
Huh.
Scamazon.
Yeah.
You need one.
Yeah, I guess I do need one.
Yeah.
Interesting. Yeah.
Could you, just if you had an AutoCAD license, could you download an AutoCAD file and slice it?
I think you can put an AutoCAD file in Fusion 360. Yeah. So the key is to export it as an STL. That is the standard for 3D printing. So if AutoCAD has, we use AutoCAD at work to I work in the IT department, but I work on construction projects, so I'm familiar with AutoCAD in the 2D perspective. How does AutoCAD do in the 3D and export an STL? I don't know.
I imagine it does instead of slices.
Yeah.
A lot of head movements and tools.
Yeah.
I did a lot
It's
of
free.
work with AutoCAD 3D, but it was 25 years ago. If
If you could, if you've got an AutoCAD license and you can you can extrude. If you can export it as an STL file, I'd be interested to put it in a slicer and see what it looks like. It does?
For DNC, it's gonna be a different file anyway.
Yeah. Yeah, it's subtractive versus additive, yep.
So another hobby I'm involved with, we needed to take these things that are kind of disorganized, and we wanted to make like storage adapters and put them in ammo boxes, so that when it seals and stuff like that,
Yeah.
but it would hold them so they wouldn't clink and it would be organized and stuff. And so the club was like really interested in it, and we needed to print about 20 of them, right, to give them to users and say, is this any value? What would you improve upon? So after we get the 20 people to say, oh yeah, that's great, I would really enjoy that product, we really needed them by the thousands. So how do you transition from something that's been user accepted by 3D printing to where you need to buy cases of them from China or whoever does plastic injection molding? What
Yeah.
is that transition? What do you do?
It's a great question. I've got friends who, like George, the Pactena people, and some other friends of mine who have made antennas. They go to, I would search on the internet and take a look at assembly shops. And there's places out there like PCB, actually, you know what? Go to PCB Hobby and see if they do, I know for a fact that they do thousands and thousands of circuit boards, right? You give them a circuit board, like Kevin next month will do circuit board processing, and all of those circuit board processing companies, they are now starting or have started to get into 3D printing, and I bet you anything, if you had a 3D print and said, I needed 1,000 of these, they would take your money.
Yeah, but we don't want them 3D printed. We want them injection molded.
Yeah, they probably have that too. Yeah.
Fusion 360 also has a marketplace where you can send out your drawing through Fusion 360 directly and have manufacturers give you quotes.
Oh, there you go.
Say, I want this cut out of stainless steel. I want this injection molded, and I've never tried it because I don't have a budget, but they supposedly will send you back quotes based on whatever you built in Fusion 360.
Do you have to have a license for Fusion 360?
No, they get a cut of the money you spend.
Gotcha. There's places out there that do that.
Okay.
Yeah. The guys that do the ham radio and coffee antenna, their latest antenna is injected molded. I don't know who they use though. That's what they told me. I don't know. They might be lying to me. Who knows?
You can 3D print molds too.
Oh, you can 3D print molds and actually probably make your own injection.
You can, forecast into
Yeah.
Lost PLA casting, I think is what it is.
It's called what?
Lost PLA casting.
Loss PLA casting?
Yeah.
Okay.
Yeah, same thing.
Just throwing this out, do they have clear
Filament?
filament?
Yeah.
Could you make a ship in a bottle, everything out of 3D?
It's not that clear. It's frosty. Yeah, it's very frosty. They have all types of different filament. They have filament that is rubbery, that you can make a ball out of. They've got
Wood grain is a cool one.
wood grain, yeah. They've got stuff that's got glitter in it. They've got, it's endless on all the cool stuff that they're doing in filament. Now, will your cheap $200 printer print it? I don't know. Sometimes you got to go into the specs and figure out, will the printer actually print this? Will it gum up? Well, might. I know that my Prusa will print almost anything, but Would I put something through it that I hadn't researched on the Prusa forums or ask somebody, hey, I want to make, Happy Fun Ball out of, my 3D printer. Can I do that with a rubbery substance? And somebody will come back and, say, well, I tried that, but these are the issues that I ran into.
One of the ones I've done, you have like carbon fiber, like certain things that are really abrasive. You'll have to get a hard tip, a novel.
Yeah. So we didn't get into it, but typically the extruder nozzle is a 0.04 millimeter. You can get bigger ones, you can get smaller ones. So the smaller the extruder nozzle, the more laps and the more layers you probably have to do, right? If you get a 0.8, it's a big swath, right? If you're gonna do a lot of printing, like the guys that do the dipole centers and they sell them, they'll do a 0.8 because they're doing 5 or 6 dipole centers and they want to run through, instead of having a whole tray be 3 hours to print, you get a bigger extruder. Now your quality goes down on the detail, but whenever you're printing something like that, who cares? So they get a bigger extruder nozzle, so instead of 3 hours, it gets cut down to 45 minutes, let's say. Again, rabbit hole. No, 4 millimeters. 0.4 millimeters. No.
What's been your most difficult mistake? Where you printed for hours upon hours and discovered failure?
Yeah. I'm trying to think because I've had a ton of failures. Trying to think of all the things that I've printed. Oh, I know. A friend of mine wanted me to print this. So those elk log periodic antennas that you can work satellites with them, and they're 2 meter and 440. This is a handle. Can I bring this up? Yeah, it's a handle. And I'm like, oh, I'll throw this on my printer, no big deal. And then you can see that that's round. It's not square on the bottom. And I spaghettied this thing 5-6 times. And I was just like, why is this not working? Well, this part's flat, right? And then we've got some overhang here, see the overhang? But it was getting, until I watched it, phooey on me for not watching it. It would not stick down here, and then it would just go ballistic once it got up to these points. Well, then what I did was let's see if I have it in my slicer. Oh no, I put it on my NAS. So what I did was I made some what are called rafts and some supports. And what happens is whenever you're printing something round in a square space, it makes these supports that are just barely touching that round handle. So then whenever you peel it off of your print bed, you can literally just take your hand and just peel off all of that support material. And then you have to get a sander, and sand it down a little bit. But it helps print round edges because it has those support layers on there. But they're not really connected. They're connected, but they're not. But you literally can peel them off. So therefore, it supports that round edge. And I went through like 5 or 6 iterations, and then I was just like, I was eating dinner or, driving to work, and I was just like, should put some supports there. That's why it's spaghettiing. So you have these aha moments, whenever you try something and you're just like, that ain't gonna work, but I know what does work, It's like whenever you discover FT8 for the first time and your clock is off by 3 seconds, and you're like, why am I not decoding? And you spend 4 hours trying to figure it out, and then you figure out that your clock is off by 3 seconds, and you're like, well, crap. Is that all that it was? Yeah. Yep. It's really cool. This handle is, it goes over the elk antenna supports, and then you can hold it, you know, at the end, and then you get like a bicycle handle, a replacement bicycle handle off Amazon, and you know, you can, because it comes with a janky handle already, and it's PVC, and it adds like 3 pounds to the antenna. So somebody just decided, you know, that's janky, man. So I'm gonna make a handle that connects to the end of the antenna, and I'm gonna use that. And I printed off one of those, got a handle for $3 off Amazon, you know, one of the soft handles. Works great. So that was solving, you know, 3D printing is solving issues that I didn't know I had, but now I printed, and I'm like, where has this been all my life?
Power outages or power glitches, do you use a backup on it or anything?
No. All of my 3D prints are low effort, low volume, low care. So if I was going to print, I had a friend who printed a, give me a Marvel comic person. What? Who? No. Captain America? No. Iron Man. He printed an Iron Man mask. And it was like 38 hours to print. And he went to Micro Center and got a UPS. But the printers today, now, if there's a power outage, it knows where it stopped, and then it will ask you if you want to continue. My Prusa now has gotten so advanced that it crashed, it hit, so sometimes whenever that extruder, it will like sometimes clump together so think of the extruder as, you know, extruding the filament, and sometimes there's just crap that gets on the outside of the hot end. Well, if that falls off and then molds to the print, and then it comes back around and it hits something, it's going to go error, I don't know what to do, and it's going to stop. And it's going to go home, and it's going to tell you, hey, I just crashed. Do you want to continue? And it's gotten so advanced now that it sends me, Octoprint sends me an email and says your print crashed. Then I can go into Octoprint and say, go ahead and restart. And then I go in and I like literally take a razor blade, because it's already molded together, take a razor blade and I take the little knob off that it deposited there, and then it starts back up exactly where now, 3 years ago with the firmware, it would have said, sorry, you're SOL. You got to start the print over. Now it's, you know, the firmware and the bed leveling and all of that stuff has gotten so advanced now that now it knows how to recover from errors. So I think that I read in a couple of firmware revisions ago that if there is a power outage, it has RAM in there that it keeps everything, and it knows where it stops. So it will reheat the print bed and reheat the hot nozzle, and it will start back where it needs to start back at. So it is, 3D printing is really cool. It is, again, a hobby within a hobby. You can go down the rabbit hole. I know that Bill and Rebecca, you guys had that burner, right? Yeah, do you guys still have that? And you've gone down the rabbit hole with that, and now, you know, you're printing badges, and you're printing this, and you're burning this, and you're burning that. So, yeah, exactly. There are so many things that I will print, and then I will use for a couple of hours, a couple of days, whatever, and then they go into the trash can. It is a hobby within a hobby. Did you have another question?
I don't know if they've had this before. The other day I was looking on the internet, and they have a device that can take failures, put them in there, they grind them up,
Oh.
recycled filament.
Yeah. See? It's just, crap like that. They,
Splicers and all that.
yeah, and they also have an app. Let's say you see something that you want to print, but you have no design skills. You can literally take a picture, a video of said object, and it will create a 3D print based on, I don't know what it's named, but it exists.
It's a 3D scanner. Just
Yeah.
pop one A.
So yeah, just put in 3D scanner, phone 3D scanner. I mean, yeah. There's Max brings up a really good point. I had my Yaesu FT2DR, kind of what George just got over there, an earlier version. The knob kept falling off of it, so I kept printing knobs. And I finally got to a point where I was pissed off that they kept falling off, so I designed my own. And then I was walking around Dayton, and it was yellow on a black radio. And a guy came up to me and was like, "Hey, where did you get that?" And I said, "I designed it." And he said, "Oh, can you design one for me?" And I look over at his hip, and he's got a 2DR with the with the knob missing. And so I printed one off for him, and then he told 2 friends, and then they told 2 friends. And before I knew it, I was printing off sheets of Yaesu knobs, and I was going to send like a bunch of them to John Kirk, the rep from Yaesu, and say thank you. You've made me a ton of money because your crappy knobs that you put on these radios. I'm making money off of your crappy knobs. So another parlay into, if you get a 3D printer, word of mouth, you design something that actually has use, and before you know it, you're charging $3 for a knob and sending it in UPS and making runs to the post office every single day. So, but I've gotten out of that because I can't keep up with it. So, that knee board was my favorite print, one of my favorite prints. Trying to think of the print that board is probably the print that I've gotten the most use out of. And, and I also printed, or I designed, let's go to Thingiverse again. So I think it's out on Thingiverse. If let's see. Let's see if it's under, is it under my name? Maybe it's under my name. Yeah. Let's see. Oh my gosh, why is it being dumb? 891. Oh, another thing that I printed that was really cool was these rails for my 891. So the rails that you can get you can put on the side of your radio to protect the buttons and the knobs if they fall off your if you're out doing a pota. I printed that and attached them, but this is it's like a casino.
Something I can hear.
So this is, let's see. Let me go to my profile. Oh, I've got a couple of things that I forgot I had done. So this is a holder. In my truck, I wanted to mount my 891 head and my Kenwood V7 700, 710 mobile radio. So I designed this backing plate that connected into a RAM mount. And it's just a ball, right? And I wanted to mount both those units together in my truck. So I designed this. I think I designed this on Fusion 360. And then the other thing that I designed was I recently bought an RV, actually like a camper trailer that just has a bed in it. It's called a hiker trailer. And I designed these breakout boxes so I could put accessory plugs, and they plug into Anderson power poles. I've been toting the Anderson power poles in the RV industry, and they're just like, what is this newfangled connector? I'm just like, oh, you're missing out. Let me show you what this is. But this is, let's see if I can rotate it here. Is it gonna let me rotate it? Anyway, you get the idea. This is just a box that sits on, I've got Velcro, and have Velcroed different boxes to different places in my RV. I run one wire, I connect it into my power pole, or I connect it with a power pole, and then it has these breakout accessories that I can, 12 volts, USB, and then I've got another power pole connector here. And I've got one of these hanging outside, so whenever I do pota, I can connect my radio into it and just draw off the house batteries for my radio. And so I've gotten a lot of use out of that too. But there's some guys out there, this is just basic stuff. There are some people out there that have, like that Iron Man mask. That was all done in Fusion 360. That thing is freaking amazing. Whoever designed that, is way, way smart. Because actually, if you go out to YouTube, I think if you type in 3D print Iron Man mask, he shows you like how he does it. Oh, and there's also this guy that 3D printed, let me show you this. Let's see, 3D printed clock, marble clock. Yeah, this guy right here. He 3D printed this. Look at the format on that printer. That format is huge. Oh, no. I ran out of power. Now, you're going to have to... yeah, that's it.
Google it yourself.
Yep. Anyway, he 3D printed this clock that brings marbles down to a plate and then tells time, and it sorts all of the marbles. This thing, oh, sorry. Playing games with you now. Yeah. Let me see if I can bring this back up. This thing, he has got this whole saga and this whole YouTube series on what he's doing, and it is fascinating. One of the coolest things I've ever seen that he is 3D printing. And then we'll be done.
Maybe.
I'm hungry. I want to go eat. Because I haven't eaten yet.
Do you do anything with mesh tastic?
I do.
I'd like to be with you on some settings.
I'm not the person to ask. I'm not the person to ask. I didn't. Can you guys see that?
Yeah.
Okay, so restore. Let's restore. Oh, and of course I got to connect to the internet because so let's go over here to YouTube. Okay, back in business. Okay, so let's get to a point where so everything that you're seeing here is 3D printed.
Including the marbles?
No. So it's called a marble clock. And it is unbelievable.
I bet that thing would be loud.
It is. It's very loud. If I turn the sound, it's going through the HDMI. And I don't think that it's picking up the sound. But he goes through the iterations of what worked, what didn't work, what he changed. It is pretty impressive. So you can see that single marble, and then see it doesn't release all the way, and things aren't lining up, and he goes through the iterations. And I think that
So every minute it has to rebuild that matrix? Okay.
Yep. I mean, look at the stuff that he's 3D printed in the back. It's just unbelievable. Let's see. So those are the.
It's got way too much time on it, man.
Well, whenever YouTube is your job and this is your job and you get millions and millions of hits, if you get 1 million hits on YouTube, that's about $4,000 worth of ad revenue. Yep. Yeah, that's a great, so you can see, okay, that's a really good question. So you can see that it's picking up the marbles here. So each one of those marbles, each one of those slots, it has a sensor to know if it's a black or a white marble. And then once it gets up to the top, there's a sorting mechanism that figures out what marbles need to go into the slots as it comes down and around. So there's a sensor and a sorting mechanism up at the top. Yep. So that it's bringing up the marbles from the trough, and then it drops them off, it ejects them, and then it knows back behind there, actually, so it's bringing up the marbles and it's injecting them into the tray. See the tray or the lines here, or the rails? So it's ejecting them, but the problem I think he's getting into, or he did, was so let's say he doesn't bring up enough white marbles to fill the clock to make it actually say a number. Well, then what he was doing was he'd eject the white marbles and they would go down, but he wouldn't get enough white marbles, let's say, the next time. So it would, every minute, a new time would have to be released and be displayed, right? Well, if he didn't get enough white marbles to make the time wouldn't be correct, and he'd be behind, right? And it would just start to spiral, and then exponentially the thing would fail. So he goes through the iteration of, how do I get enough white marbles up to the top so I can make the time, but then I need to make sure that I have enough black marbles to make the numbers pop, make the white marbles pop, but the black marbles are just filler. It's the white marbles that you need to make the time, right? So he has this whole algorithm that he goes through, and he's a great explainer on how he did it, what his issues were, how he solved them. It's great. And he's only made 6 or 7 videos about it on his channel, but they're fascinating.
So is his subscriber count 519,000?
Yeah.
Is that what that says?
Yeah. Yep.
That's a pretty big channel.
Yeah, it's a pretty big channel. Yep.
What's his alarm clock version of that?
Yeah.
I don't think you're gonna sleep during it.
So,
Rail one.
yeah, so these, So part 2 here is 4 million views. Part 3 is 3.5 million views. His first part 1 was 1.5 million views. So I mean, it's not typically a video that gets 1 million views is anywhere between in ad revenue $3,000 to $4,000. So, but it's it's not. Let's say it's $3 million and it's 3 million views. It's not $9,000. He probably, after it was all said and done, this video that got 3.5 million views, he probably made $5 or $6 grand on that video. Now that's pure cash, right? You gotta pay taxes on that. But getting 3.5 million views on a video, it's tough. It's real tough. But whenever you're doing cool stuff like he is, it deserves it. He's put a lot of time and effort into something like that. And keep in mind, all of this is 3D printed too. It's all 3D printed. You can see him putting the relays in.
Did you say how long it took you to 3D print it?
Yeah, he does in the video. I mean, it's literally like days and weeks, It's not like he's putting to, he's got these ESP32s that he's putting in. I don't know, those aren't ESP32s. See, he's soldering all of the connectors together.
He's also got a lot of edit time in there too.
Oh yeah. I mean, he's probably got weeks and weeks and weeks of time into something like this, right?
So overall, he's making about $3 an hour.
Probably, yeah. Yep. Yep.
I got a question.
Yeah.
Since you started the 3D process, how long does it take you to go through the learning curve and start being able to design stuff and do that sort of thing?
Back whenever I bought my printer, getting the bed level was the hardest thing. It took me weeks to get the bed level. And that was the hardest part. I'm talking 5 or 6 years ago. Today, you can go and buy a 3D printer off of, tonight, you could go to Micro Center and give $350 and that bed will level itself and you will be printing that benchy tonight. The technology has come so far lately that it is, especially $1,100 printer, the new Prusas that just came out, they're all self-leveling. You don't have to level the bed. And that's the hardest part. The design process is tough though. I struggle with the design process. But if you start with Tinkercad, if you have an engineering mindset and you can visualize what you want to design, it's not that tough. Now, if I put my sister in front of a Tinkercad and said, "Here, design this box on Tinkercad," she wouldn't know where to start. But if I, put this in front of my 18-year-old cousin who's going to Rolla and she's, wants to be a mechanical engineer, she'd get this down in no time. So it all depends on how much time you want to put into it also and how smart you are.
You bought a printer that works for you, and does that have its own fixing of the bottom, adjusting that, or?
No, well, whenever I bought the printer, it didn't have like a level bed. I had to put it all together. Today, you can literally, this printer probably comes all assembled, right?
It's like 30 minutes or so.
Yeah, you literally pull it out of the box, you probably put the case on it, and you're printing. It's so much more advanced now and so much easier to get into the space than it was 5 years ago, 7 years ago, whenever I bought my printer.
This one is so smart, it does the bed leveling. You don't have to think about it. When you put in a spool of filament, there's an RFID tag inside the spool that says, you bought Bamboo Labs green PLA. I know exactly the settings to print green PLA. And it'll come out perfectly.
Yeah.
You pay a little premium for it. But.
It's so much easier now than it was, 5 years ago. Right. Yeah.
Buy once, cry once.
Yeah.
Except for they just came out with a new version of this one like 2 days ago.
Oh.
For your 3,500.
I like the buy once, cry once mentality because I hate to tinker. I just like things to work. So I tend to, whenever, like, I buy my radios and I buy my ham radio equipment and I buy my 3D printers. At the time, whenever I bought my Prusa, the thing was $1,100. It was a kit, but it was the best one that you could buy. And I had friends that literally, they still have old Creality printers that they've never gotten the bed to be leveled. At the time, whenever I bought my Prusa, that was the easiest bed to level and the easiest one to get working. And should I upgrade? If I bought a Prusa today, if I went on Prusa's website and bought a Prusa today, I wouldn't have all the woes that I had whenever I started, because they've solved them.
So does that mean that with the 5 or 6 year old printers that you have to struggle with to get working, that the value of those is really diminished, like the resale value of them, like people who really don't.
I don't know.
They have no resale value.
They have no resale value.
Because the new, you can buy a better $200 printer now than the $200 printer back then.
Yeah.
So the people that bought the $200 printer are not very happy with it anymore and gave it away to their buddy Bill to make him suffer.
Yeah.
So then the goal, when you were doing all that struggle and frustration, the goal was to get Benchy to print. Was that the goal? And then you kind of.
I just wanted to print to begin with. Like, my first probably 10 prints were all spaghetti. I just wanted to print, like, literally just something like a box that had, that had no overhangs or, none of that. None of this crap that you're seeing. I mean, look at this stuff.
What is that channel?
I don't know. It's a short that I brought up. You just put in 3D print and on YouTube, and it's crap like this, right? These are the cool things, and there's so many techniques. See how it's like, he's got the torch out and he's taking all the imperfections off of there, and then you can take acetone and rub acetone on there so it takes the 3D printed finish off so it doesn't look like it's 3D printed. There's so many tips and techniques that you get from just watching YouTube videos, and also they've gotten to the point now where like that tongue is all 3D printed together, and then you just break it apart and it is all it's all loose. Yeah. I printed the first thing that I printed that was all flexible. I printed a stand for my tablet, like just a stand, like a stand on a table, and it printed flat. I popped it off, and then the hinge was printed there as a hinge, and I just snapped it out of its placement, and it flapped back, had it a full range, and then this other arm that came and it flapped it, and then it had a triangle, and I set my tablet on. It's just like, I would have, my parents would have paid $20 for something like this on Amazon, right? And I just printed this in 4 hours, and it's exactly what I need.
Just curious, have you seen the 3D printed house down in, Cairo, Illinois?
Yeah, I saw a video where they're printing concrete, right? It's extruding concrete. Yeah.
They've got a completed house now.
Oh, they do?
Yeah. It's the first one in Illinois.
Yeah.
And Brendan, if we can get some property, we can 3D print our shack.
Yes.
Yeah, that would be awesome.
Yeah, that's a completed house now.
That would be expensive.
Well, it's
Building a house.
yeah, but it's not very pretty, is it? It looks like extruded concrete.
Yeah, but that concrete delivery guy is gonna sit there and charge you money while he's emptying.
You just put siding on your house.
Or stucco finish.
Yeah, stucco.
Yeah, stucco. Yeah.
That is nuts.
But yeah, I actually drove down there to see, and it's a modest house, because it's like, it's for cheap housing.
Yeah.
We have such a housing issue down there.
Yeah.
And this was a cheap way to do it. Imagine your contractor shows up with a laptop. Okay,
Yeah.
Tilt up buildings, you ever see that where they lay the concrete and then they form it and then they lay it up vertically?
Yeah.
Well, they use it everywhere, but at one point, that was a new technology.
oh, okay.
It was.
There are so
Now-
many
now it's
different
everywhere.
building technologies out now, it's unbelievable.
It's called tilt up.
Oh yeah. We created a tilt-up building. Yeah, for BJC. I work here, and yeah, we had our new medical office buildings that are less than 3 stories are all tilt-up. Yep.
Yeah, we can build our shack.
Can. All right. Anything else?
Great presentation.
Thanks.
Yeah.
Thank you.